So we're going to pick up where we left off last time with more discussion about the Java ForkJoin framework's ManageBlocker mechanism, its interface, its behavior, and so on and so forth. And we're going to talk about how the ManageBlocker interface helps avoid starvation and improve performance, particularly for blocking operations. And what's interesting to note is that this mechanism isn't just limited to Java's common ForkJoinPool, and I'll talk a little bit about how it actually works shortly. It's a little bit mysterious at first to understand how it works and why it's useful for other ForkJoinPools, but you can use it with many pools, not just the common ForkJoinPool. So let's start by talking about the ManageBlocker mechanism. So the Java ForkJoin framework was initially designed for tasks that run to completion without blocking. That was what was provided in the Java 7 timeframe, the 2010 version. And so that's what it does. So things that don't block, they start to run, these ForkJoin tasks, they run to completion, and they're finished. However, many apps perform blocking operations on input and output, on synchronizers, on bounded buffer queues, and so on and so forth. For example, your assignment does this. It'll block on several situations. It blocks when it's downloading stuff. It'll block when it's writing stuff, and so on and so forth. And you can actually see the symbols. If you slow down the speed, you can actually see symbols when it's doing various blocking operations. Therefore, there's a mechanism that was added in Java 8, which is the ManageBlocker mechanism, which handles cases where more worker threads are needed in order to ensure liveness and responsiveness for blocking operations in any ForkJoin pool, not just the common pool. The idea here is to automatically and temporarily increase the common ForkJoin pool size, kind of like stores hiring extra workers for the holiday season, like Walmart, for example, or Amazon hires seasonal workers to put more packages and route them through their delivery system. The ManageBlocker mechanism, as I said, can be used with any instance of a Java ForkJoin pool, and here is how it does this. This is really cool. If you take a look at the source code for the ManageBlock method, which is a static public method defined in Java 8 and beyond's ForkJoinPool, you'll see that it checks to see if the calling thread, if the thread that's calling ManageBlock is indeed an instance of a ForkJoin worker thread. And if so, it goes ahead and uses the pool that's associated with that particular thread, and it calls this method called compensateBlock. And we'll talk more about that later. What compensateBlock does is it essentially will add an extra thread to the pool to compensate for the fact that there's going to be a blocking thread that would otherwise soak up a thread and make the pool only have fewer threads. This increases the number of threads. So that's a pretty cool thing. And as usual, as they say, to paraphrase Star Wars, use the source, Luke. So you can use the source to figure out what's going on. Of course, you could also just ask ChatGPT, and it would tell you as well. But using the source is a good way to confirm that it's not hallucinating. The common ForkJoin pool reclaims threads during periods of non-use and then can reinstate them later if need be. So it basically has this sort of Reaper facility that has this life cycle of threads, sort of like the samsara life cycle of reincarnation. It puts them to sleep or kills them and then brings them back and reincarnates them at some later point. What it tries to do is it tries to create or activate threads to ensure that the target level of parallelism is met. So it's basically a control loop, like a controller, where you're trying to make sure that you have the right number of threads available at any given time, up to some limit. There's actually a limit on this stuff, but it's a fairly large limit. So now that you know a bit about the mechanism, let's talk something about the ManageBlocker interface. So there are two methods that are defined on the ManageBlocker interface. And the first one is called isReleasable, and that returns true if blocking is not necessary because something was able to acquire the resource without having to block. For example, you might have some kind of a synchronizer, and you might try to acquire the synchronizer without blocking. And if you manage to get it because of the luck of the draw, then you're out of the woods, and you don't have to worry about blocking at all. So that's the isReleasable method. And then there's another method called block, which possibly blocks the calling thread, waiting for a lock or an I/O operation. And as we'll see when we look at the actual implementation in the source code shortly, if block is called, if you need to call block, that's when compensation takes place to add extra thread, an extra thread or extra threads ultimately to the underlying fork join pool. And this returns true if no additional blocking is necessary, if for some reason we managed to get lucky and we got the operation right away. So let's take a look at how the fork join pool implementation in Java, and Java 8 and beyond, applies the ManageBlocker mechanism and the ManageBlocker interface. So it uses this internally to do its thing. And you can see here that the ForkJoinPool class extends abstract executor service, blah, blah, blah. We don't care about that right now. And this has a ManageBlock method. And we looked at some of what it does earlier, so to find the right thread that it needs to use. So what this thread does is what this method does, it'll activate a spare thread to ensure sufficient parallelism while the calling thread is blocked, or if the calling thread happens to block. And here's what it does. It takes an instance of a ManageBlocker. That's what you would define, or you could use a helper class like the blocking task class that we use for our assignment. And ManageBlocker is the interface that's used, we just talked about, to expand these threads. So let's take a look at the code. So it'll check to see if the blocker is not releasable. So in other words, we didn't manage to get what we were looking for without having to block. So now we're going to have to block. So we're going to call the try-compensate method, which will create or reactivate a spare thread to compensate for the blocking joiner, the thing that's trying to block here, until it unblocks. And you can see here, once that happens, we go into a do-while loop. And while we are not able to get while the blocker is not releasable, then we're going to go ahead and call the block method, or rather the ForkJoinPool is going to call it the ForkJoinPool ManageBlock mechanism is going to call the block method on the ManageBlocker parameter, and that may indeed block the calling thread. So at this point, we've compensated. There's an extra thread that's created, but we may block now, which is OK because we've added an extra thread. So that's the end of the overview of Java's ManageBlocker interface and the mechanism that implements it underneath the hood.